In today's session, we are going to discuss about operations on processes. So, what are the operations we have on a processor? As I said earlier, process is nothing but a program in execution is called process. So, what are the operations it have? So, this provides two things. One is process creation and process termination. So, these we are going to see in this session. So, first is process creation. So normally the parent process create child processes, which in turn create the other processes, forming a tree-like structure. So what is it? A parent process will always create a child process. After that, the child tends to create the other process, and it will be like a tree formation. Generally, the process identified and managed via a process identifier. So all the process will be identified by a process identifier, that is PID, which is called as PID. Here we have resource sharing options. So whenever a parent is creating the child, it is going to share the resources of the parent. So this has the following options. One is parent and children share all the resources. Whatever resources the parent is having, it will be shared by the children. Then a children share subset of parents' resources. A subset of parents' resources can be shared by the children. This is one option. Then parent and child share no resources at all. So this is another option. So it shares all the options or shares all the resources. That is option number one. Or it can share a subset of parents' resources. Okay, a part of the resources. Then it shares no resources. The child shares no resources with the parent. The execution options. Parent and children execute concurrently. Normally the parent and children execute concurrently because the parent has created the child process. And parents wait until the child terminates. Okay, the parent process will normally waits until the children terminate. So this is the tree like structure of your process. Okay, the parent child here creates three child process. In turn, the child process has created many other processes which are followed by that. So it is yeah, tree like structure. Then address space. The child duplicate of your parent. Child is nothing but it is a duplicate of your parent. A child has a program loaded onto it. Okay, if you created a process or a parent is going to create a process, so the process is nothing but a program which is in execution. So some part of program will be there in the child. Then example has been given from Linux. The fork command is used to create a new process. So when you are asked like this, how can you create a process? You can say that by giving a fork system call, we can create a new process. Okay. Then execute system call used after a fork to replace the process memory space with a new program. So fork and execute are a function which is used to create a new process, and execute which is used to replace the process which is residing in the memory. Then so this is a C program forking separate process to create a process. So that is header files which are given first. Then there is a main program. Here in the main function, PID underscore T, then there is a gap and PID is there. So we are declaring PID, then fork a child process. So to create a child process, we are giving a fork command. PID is equal to fork. Okay, so that command is used to create a child process. Then we have a if else function. So if PID less than 0, we should say error will occur and the fork command will not work, so it is failed. Okay, we are going to print that. Then else if PID is equal to 0, then child process will be created. Okay, a child process will be created where we don't have anything inside it. Then else a parent process will wait for a child to complete. Okay, if PID greater than 0, the parent process will normally wait for the child to complete. Okay, so this is how for command will be given for creating a child process. So here also it is for creating a separate process via Windows. Then next we are going to see is process termination, how a process can be terminated. As already said, you can give exit system call to terminate a process. A process executes last statement and then asks the operating system to delete it using exit system call. Whenever a process has been executing the last statement, then the statement or function will be exit system call. So if you give that exit system call, it returns status data from the child to process via wait command. So what is the status of child? It will be given. It will be returning the status of child. Then the process resources are deallocated by the operating system. Whatever the resources has been given to that process will be deallocated by the OS. So this is what will be done when the process is going to terminate. Parent may terminate the execution of children process using abort system call. So whenever a process is going to terminate, the child process will also terminate. For doing that, abort system call will be given. Okay. Some reasons for doing so. Why we are doing or why we are giving the abort system call. The child has exceeded allocated resource. So if the child exceeds the allocated resource, this abort system call can be used. Task assigned to children or child is no longer required. When we don't require any uh, task from your children, this abort system call can be given. The parent is exiting the OS does not allow a child to continue if parent terminates. If parents want to terminate, then the child needs to be terminated, so it can give the abort command. Then some operating system do not allow child to exist if its parent is terminated. Most of the OS will be doing like that. If a process terminates, then all its children must be terminated. Whatever the children associated with that parent has to be terminated. So cascading termination, which is called as cascading termination. All children, grandchildren will be terminated once the parent is terminated. Okay, this termination will be initiated by OS normally. The parent process may wait for termination of a child process by using a wait system call that we have seen. So whenever the child has to terminate, the parent will wait some time. So for that, a wait system call has to be given. The call returns status information and the PID of the terminated process. So the system call will return what? The PID. What is the process ID and what is the status of that? Okay, so that will be stored. If no parent waiting, then the process will be like a zombie. Okay, no parent is waiting the children to terminate. It is like someone. If parent terminated without invoking wait, then the parent can be called as a orphan. Okay, so this is process termination. So these are the two process operations we have. One is process termination, one is process starting. Okay, so this is the operations on your